Hello and welcome to another Solana tutorial. Today we're going to talk about deploying programs. Because I want to figure out what actually happens when you deploy a Solana program. We did have a look at on-chain programs and their accounts in a previous video, and I recommend that you watch that one first, such that you have an understanding of, the state of programs. But today I want to deep dive into what happens if you Solana program deploy, and then maybe figure out how to deploy a program in one transaction. But that's an esoteric goal. Currently, you need 3 at least. And then in the end, we might also have a look at what happens if you close a program, what remains on chain. And yeah, basically just learn about how the upgradable loader on Solana works. Because it's such an essential thing for Solana devs, because when you write an on-chain program, you're gonna use the upgradable loader to deploy your programs. And again, as last time, you can of course go your Solana journey without understanding this and just use the Solana CLI to say Solana program deploy and it will be fine. But I just like to have the knowledge of what's actually happening, and that will also help me in case I ever want to deploy a program from my own program. Have my own script that deploys Solana programs, or do some optimizations around the deployment of programs or something like that. I want to just do a deep dive because then we learn stuff. That's the only way how I learn, by doing things. And I'm so excited to finally do this and play around with Solana program deployments. Let's go. This is going to be a good one. I'm already excited about it. Here's my current understanding of how this works. To deploy a program, you do 3 things essentially. Well, first you will need to write your program and then build your program. But once you have the built program, then you do 3 things. Number 1, you create a buffer account. That's just a temporary account, also owned by the upgradable loader, and you put enough sol in it and allocate enough space for your program. Then step 2, you actually upload your program, so the binary file, the SO file, transaction by transaction onto this buffer. So you basically write the buffer. We need several transactions for this because we have a transaction size limit and our binaries are longer than the transaction size limit. Plus each transaction has an overhead. You can only put so much data into one transaction. So I'm assuming it's instruction data that is sent to the upgradable loader with a special write buffer instruction that writes the buffer. I don't know, never looked at it, but that's what I imagine happens. So that's step 2. And then as step 3, once you've uploaded your program to the buffer, you execute another instruction on the upgradable loader that will take all the data from the buffer account and write it into the executable account. If you don't know what that is, watch the other video. So that last step, that's one transaction. That's important, because transactions are atomic and you don't want to have any weird states in between. It's either that version of the program being executed or the upgraded version of the program being executed. And there's one transaction that changes it from the old one to the new one. And then after that transaction, the program will behave differently. So that must happen in one transaction. Otherwise, you would have inconsistent state and it would just be, So it's important that there's this one transaction. So essentially, you deploy every program in exactly one transaction, one could say. But really, before you can do that one transaction, you need to write the entire program to a buffer account. But then again, you can write several buffer accounts and that's not actually deploying a program. So it depends on what you see as deploying a program. You always deploy a program in exactly one transaction that does exactly that one thing, because you wouldn't update a program. You can't just write to the executable account directly, because if you write several chunks, at some point it gets inconsistent and then the program would do something weird and crash, and we don't want that. So that's why we have those buffer accounts. That's my understanding of how deploying a program works, and that's good enough for 90% of the people, but not for me, because I really do want to learn more of how exactly it works, what those instructions look like to that program, just so I have more knowledge and I can play around with it more. And maybe there is a use case where I want to change some stuff or make it custom. So yeah, I just really want to have a look at that. And that's what I allow myself to do today. So I'm super excited to finally get started and look at the upgradable loader. Let's go. Okay, where do we start? The CLI. There we go. There we have the releases. Okay, so it's basically in Agave. So that's the former Solana Labs client. And there we have the CLI. Okay, so it's maybe all in that huge monorepo. That's where the CLI lives. There is program deployment. Yeah, let's have a look at that. We're gonna clone the entire repo. Why not? This is a big repo. And here, with all those things, we find the CLI. My favorite way to learn how stuff works is just to look at the source code. It used to be deploy, but that I think is deprecated. I guess I need to let this build first before I continue. Okay, we're doing cargo checks now, and I'm still laggy, yes. Oh, did it just finish? Are we back? Huh. Okay, 20 minutes later. Let's have a look at this. Yeah, there we go, that works. This command is not supported any longer. I told you that is deprecated and completely removed now already. And then we have program and program v4. That might be the topic for another video, because I have no idea what that is. You can also deploy it. The regular one here is in program, process, program, subcommand, and here we have the subcommands for deploy, for instance, which processes program deploy, which deploys a program using the upgradable loader. Can also process program upgrades. Don't ask me what the difference between the normal program and the program v4 is. We might figure that out eventually, but since this is also already dealing with upgradable loader, let's just look at that for now. So we get the fee pair, we get the upgrade authority, and then we create an ephemeral key pair. So that's a temporary key pair for the buffer account, and it will print the mnemonic if it fails. That's why I always recommend actually setting some buffer such that you have a buffer provided. Otherwise it's not provided and you get that key pair. But I recommend to, provide one. I get the default program key pair. That's the thing that we usually have next to our program, the dash keypair.json at the same location where the program SO file lives. If there's a key pair there, that's the one we get here. Otherwise, we can specify another one, so that's the default, but we can specify the pub key manually if some config is set. Basically, we just get the program key pair. That's not the interesting part. Or the program pub key. We just need the key pair or assigner. If we deploy for the first time, then it's just the upgrade authority that needs to sign. Only the first time when we actually create the program account, that's why we need to sign for that one. Or we do it with a system program account from seeds. Also made a video about that neat little trick, but that's not what we're analyzing today. So let's just continue. So for the initial deploy, that's when we need to sign. So here we get account with commitment. If the owner is not the upgradable program, then we say, hey, this is not an upgradable program. It's owned by another program, or it's an account that is already in use in some other way. If it wouldn't come back here, so if we don't have an account, then we do a new deploy. Is this true here? So that's the do initial deploy. And if we get a value for that account already, then we check if it's executable. Because if it's not executable, then the account exists, but it was never set to executable. So we do an initial deploy. And otherwise, we need to check the upgradable loader state for program. We did have a look at this last time. That's a program account that has the program data address. We first see, hey, can we make this a program account? Is this a program account essentially? If so, we read the account for the program data address, which we have from in here. So we check if it already has a program data address written. Then we read that and see if it has a slot and upgrade authority and so on. And if there is no upgrade authority, then it's not upgradable. Yeah, of course. And if we don't have the matching authority pub key as our program authority, then obviously it doesn't match the provided authority. And otherwise we can just do a normal deploy. And that else the program has been closed comes when? If we don't have that account. So I guess that answers our question. What happens with a closed program? The program data address, that account will not exist anymore. If that account doesn't exist, that means the program has been closed. That answers my question to what happens when a program is closed. Because as I mentioned last time, but I think I cut that out of the video, a program account will never be deleted for security reasons. such that you can never redeploy a program to the same address after it has been closed. And the way this is done is that the program account stays and only the program data account will be deleted. So in order to see if a program got closed, you just need to check if the program data account got closed. And since the program data account is a PDA of the BPF Upgradable Loader, the BPF Upgradable Loader has control over whether or not that account gets created or not. So you can't just, recreate that account later. Seems safe. Seems cool. Okay, there we go. Learn something. Right, so here we say false because we just do an upgrade and not do initial deploy. Then something about feature sets. Don't ask me what that does. Let's ignore it for now. Then read and verify the ELF file from the program location with a certain feature set. Okay, there comes the feature set. Okay. Basically, we read the binary file, the program data, check the length, store the length. If we have a buffer provided, then we need to check if that guy exists, and we check that it has the required length, and we check that we are the signer. So we check that it's owned by that program, that we have the authority, that it's not immutable, this buffer, and that we have enough space in that buffer account. And then we actually already read the data and we split off the metadata. See here? That's interesting. Size of the metadata, because the metadata of the buffer account, is this guy. And then afterwards comes the actual program data. So if you want to have the program data, you need to split off those 37 bytes from the data. Then we get the actual buffer data, which we return here in this function, the fetch buffer. So that's the program data. And if we don't have a buffer provided, then of course that program data is also none. That we return with the program data and the program length to here. That was if we have a program location. If we don't have a program location, but a buffer provided, then we do the same thing just with a buffer. And for the program location, we use an empty vector and the buffer program data length. And otherwise, if neither buffer nor program is provided, then we fail. What is this part? I guess by doing that, you can provide the buffer only. You can do that without providing the SO file and deploy a program if the entire program is in the buffer, I assume. Then we check that we have enough length in our program account. So the max length, we set that here as an option. Okay, sure. Then rent exemption, and then we'll finally do stuff. If we do an initial deploy and we don't have a signer, we fail. And then we actually do the program deploy with all of that. And otherwise we do the program upgrade. So there it distinguishes between the initial deploy and the upgrade. And if we are okay, then we process a set authority. If it's final. Then we set the new authority to none. So this is basically making it immutable. So there's a final flag. That's how you make a program immutable. There's the -- final, I guess. And if you have that, then you do another transaction to do this, make it immutable. And otherwise, if we have an error and we didn't specify the buffer, then we report those ephemeral mnemonics, which is something that I actually don't really enjoy about this. That's why I always recommend that you use an actual buffer provided, like a buffer key pair for deploying a program. Because if your CLI gets stuck somewhere on the way, which happens to me, and then you accidentally hit Control-C to stop the deployment, but the buffer account was already created, then you don't even get those words to restore your buffer account. There's still a way to figure it out what that account was, and you can probably still somehow get it, but still, I don't like that that's only happening here, and I just prefer to avoid working with this temporary key pair if I put actual sol on that account. Anyway, that's just mine. But I've mentioned this in the verified builds video. Verified builds video, let's promote it. That was the one big takeaway there. Yeah. And that's the entire deploy. So it just does the do process program upgrade or deploy. And I guess we need to look at that now, shall we? Good, okay, fine, let's look at the program deploy. So there we actually do transaction sending because we do get a recent block hash. Okay, so here we build the instructions for this initial deploy. Okay, perfect. The initial instructions, this thing, is just a create buffer unless we already have some buffer, then we don't need any balance and we use that buffer data. Otherwise, we need to create that. Good, then the initial message, if we have initial instructions, is just, we put in the block hash and we add compute unit, price and limit. those initial instructions, which is just 1 or 0. If we have 0, we don't have that. Working with options in Rust is nice anyway. Then we create the write messages. So that's now the interesting part. So that was the first message, just initializing the buffer. That was step 1, if you remember from my intro. And then we add all of the write messages. And here it might get a bit complicated because I think that thing is pretty smart. What we do is a BPF loader upgradable write instruction where we write to a buffer. We need to provide the authority of the buffer. We need to provide the offset and we need to provide the bytes. And I guess this has a fixed length. We should probably look at this. Yeah, let's do it right away. Why not? Can I somehow figure out how many bytes? I mean, it's a vector, so this thing knows how many bytes it is. Buffer address and authority. So building this instruction is not particularly complicated. Basically, just the instruction data will be this offset as a U32, then this vector of bytes. It's a vector, so it knows the size. The first 4 bytes of the vector tell me the size of the vector. That's the instruction data. Those 2 are the accounts, and with that, call the upgradable loader program. Easy. And then to this instruction, we add compute unit stuff. And then we make a new transaction message with a block hash and this fee payer. Easy. And that is a function, actually. That's how you define functions, nested functions in Rust with this thing. And then this. In TypeScript, you would do that, with the equals arrow thing. Just different syntax. But yeah, here we define a function. Then we make a vector for our write messages, which we'll then build actual transactions from. We calculate the chunk size. Calculate max chunk size. Haha. Interesting. So the baseline, it takes that function that builds our messages and just creates, an empty one. So basically at offset 0 and send 0 bytes. Build a transaction from that, check what the size is, and then we have packet data size. So that's the max transaction size, because 1280 is IPv6, and then we have 40 bytes of the IPv6 header. 8 sites is the size of the fragment header. So we have this minus 48 is this. If you ever wondered how to calculate the actual max transaction size, so the Solana max transaction size is this, because IPv6 are the layers below on the networking stack. Okay, cool. So that's then how you also subtract 1. Add 1 byte buffer to account for short vec encoding. Okay, so we need to subtract 1 more than this that minimal transaction size. And then we get the chunk size. And with that chunk size, we can then create as many transactions as we need with that chunk size. So the entire program data, split it in chunks. However, if the program data is 0, because it's already all in the buffer account, then that will be 0, and then chunks from that 0 thing will just not give me anything. So then we'll have no chunks. Then the write messages, there will still be an empty vector. Don't ask me why we zip that with a 0. And then we have offset for I times the chunk size. And then the chunk is write message push. We create the message, that's the function that we created up there, with the offset and the chunk to a vector. Nice. And then we have the write messages. That was part 2, and then comes part 3, the final message. The final message. It's the final message. Diddly-doo. 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 And the final message consists of the following instructions: a deploy with max program length and the compute budget stuff. So again, I think that's just another one instruction: deploy with max program length. That gets the payer, the program, the buffer, of course, the upgrade authority, and program lamperts, which is size of program. Get minimum balance for rent exemption. So that's the size of a program account, 36. And then, wait, but that's not enough lamperts, because there's still the program data length. It will need more lamperts, but maybe takes that when it does the deploy. So maybe the program itself does that already. That's weird. Gotta have a look at that. And yeah, anyway, then we create a message with those instructions and the fee payer and the block hash. Yeah, pretty simple. So then we have the three things, which is the initial message, so step 1, the write messages, step 2, and the final message, step 3. There are some checks, final transaction signature, and then we send all of that with the initial, write, and final, and only get the signature for the final, and we print that. Send deploy messages probably does nothing super special. It's just the logic for, sending the transactions. If we have an initial message, we send and confirm this one. If we have write messages, send those. Oh, with quick we can do in parallel. And then if we have a final message, that's the deployment of the program. And it always first does a simulate and update compute limit. That's not the price, that's the compute limit. It simulates and changes the limit for how many CUs are requested. It changes it in the message because that's mutable. And then it signs that again with the signers and then send and confirm transaction. Pretty simple. Cool. That's it. Those are the 3 steps. So we confirmed what we already kind of knew, but what is new? There was something that I wanted to have a look at. But here, the building of the deploy with max program length. What does that actually do? Gets me the program data address. That's a derivation. We saw that last time as well. There. With the BPF Upgradable Loader and the program address as the seed. And then, so here it does a create account where it creates the program account. It seems to me that that should be optional depending on whether or not that account already exists. But the CLI always does it together. So when you just use the CLI, that will never happen that you create that account without. If we play around with it, we could, make it fail by already creating this, but we could have that in 2 separate transactions, of course. Anyway, we have it in one. So the instruction is new with bin code. That's the program ID. So that's the BPF Upgradable Loader. And then that's the data, which is deploy with max data length So that's the only instruction data that we have. The instruction discriminator plus the U64, I guess, or whatever that needs. A U size, I guess U64. And then the accounts, which are the payer, the actual program data, then the program, then the buffer. And then it still needs rent, clock, system program, and my upgrade authority for some reason. As a signer. That makes sense, but not writable. And see, that in my opinion is good layout. Splitting the payer from the signer or the authority. The payer should also be a signer, yes. But it doesn't force you that the authority is also the payer. And I kind of like that. Because then you can have, whatever as the authority. Even, let's say, a PDA. It means we need to put in one more account. But that's just 1 byte. If it's the same account. If it's 2 different accounts, yes, it's 32 bytes that we add to the transaction. But we don't lose from having 2 accounts here because those will then just be serialized in a 1 byte account index. Anyway, overanalyzing things again. But what I'm saying is I like this kind of a layout where you split the payer from the authority. And I wish all programs would do that. But most of them, also my first programs, were just like, oh yeah, we need the signer. And the signer pays for everything. And the signer is also the authority. But logically, it's really nice to split those 2. Anyway, I'm talking a lot. Right, so that's the real instruction after creating the program account. It's so interesting. We create the program account in our final transaction if we do the initial deploy. And then I guess this instruction, the deploy with max data length, will allocate more data. And that's probably why it needs the system program, because it will allocate more data to that program account. And to actually look at that, it would be so nice to, look at the actual implementation of the upgradable loader. Should we also do that? That would be fun. That should be in here as well, right? Programs, we have programs. Yeah, BPF loader. Do we have upgradable loader? No. There's a loader v3 interface upgradable loader state, and there's a loader v4 interface. Maybe I do want to look at what the difference is. Ah, this is for the program runtime v2. Right. Let's not look at v4. Let's just stay with upgradable loader in v3. An upgradable BPF loader native program. It's so difficult to find stuff in this. We've got built-in programs RS. BPF loader upgradable in programs. Where's that? Isn't that for benchmarks? Tests? Yes, that's just tests. Upgradable loader state is used here. Maybe this stuff is for the upgradable loader. Process loader upgradable. Aha! It's all in one file. I see. All of the loaders are in one. What could possibly go wrong to have all of the loaders in one source file? Yeah, I mean, it's just 4,000 lines of code anyway. Pfft, easy. Okay, good. Let's look at where the upgradable loader instructions are processed. We can have an initialize buffer instruction. We can have a write instruction. We saw that with the offset and the bytes. What does that actually do? Checks, checks, checks. And then we write program data at the size of buffer metadata plus offset. We write those bytes. Yeah, nothing unexpected here. That's the write. Then we have the deploy with max data length. Apparently that's the only deploy there is, or is there more? Let's look at this thing. What instructions do we actually have at the upgradable loader? We have the initialize buffer, we have the write, and we have the deploy with max data length. And then we have the upgrade. Oh yeah, we didn't look at that yet. That's for the initial deploy. That's for the redeploy. And then we can set authority and we can close the program. And this one was new. We can extend the program, so we can add data size, and then we can set authority checked for a buffer or a program account. This instruction is check that the authority is also a required signer, that you don't accidentally set the authority to someone who can't actually sign, which with this one, apparently you could do. Yeah, okay, so those are the 5 instructions of the upgradable loader. Don't ask me why they call it deploy with max data length and all the others have such nice short names like write and upgrade. But yeah, it's deploy with max data length. There is no other deploy, but it's deploy with max data length because it takes instruction data. I mean, this is also not called write with offset and bytes. I mean, okay. Anyway, cool. Where were we? How did we get here? We looked at those instructions. Okay, we were here. So at the processing of those instructions, when we actually deploy, what happens? This is we're looking at source code video, but I like it. I like looking at source code. I'm gonna go through this quite quickly. So of course we do some checks. Oh, feature set. If it's active the loader v4, then this instruction is not supported anymore. Aha. We get a new loader, probably. Or we get new instructions to the loader in v4. Something like that. But yeah, if we have the v4 feature set enabled, then we can't deploy with max data length. We're not going to look at that v4 stuff now. In v3, we just continue. We check that we have at least 4 accounts because we need the payer, the program data, the rent, and the clock, and the authority. Maybe. We verify the program account, that it is uninitialized. If not, it's already initialized. We verify that the data length is less than the size of the program. Why is there a less than? Okay, that's why, because we error, it must be greater than or equal to this. Oh yeah, that makes sense. And if it's smaller, then we error. Yeah, makes sense. Okay. And then the same with the Lamberts. If the Lamberts are less than the minimum balance for rent exemption, then you also throw it, okay? And then drop program. What does that do? Is that a Rust thing? This is memory stuff, I guess, such that we can then borrow again. They could also have, you know, curly brackets here and here, such that it's then dropped again. But here it just explicitly, ooh, I'm learning Rust as well. At least that's what I think that it does. It just drops that reference. That's cool. Ha! Because we don't need it anymore. We have this new program ID and we're happy with that. We don't need the reference for this borrowed stuff anymore. Because otherwise we get an issue with double borrows and stuff. Okay, then we verify the buffer account. I assume we do similar things here, checking the authorities. And then we get length and stuff and stuff and stuff and stuff. We do the same thing with the drop here. Max data length is too small to hold buffer data. So max data length was what again? Oh yeah, that's the thing that we put in as instruction data because we deploy with max data length. Great name. If that is smaller than what's in the buffer, and the max data length is just the additional data length for the program, not for the entire account, because the entire account will also have the metadata of the program, you know, this stuff. This will be additional to the max data length. So if the max data length is too small, then we error. If the program data length is bigger than the max permitted data length, which is 10 megabytes, then max data length is too large. And don't we here still somewhere add the metadata? Or is the program data, does that include? Yeah, that includes the size of program data. So that is the size of the program metadata plus the program length. Yeah, that makes sense. Okay, so we're not missing that. Cool. So that's the max data length plus the metadata for the program. If that's bigger than the max account size, of course we fail. And then finally we do something interesting. We create the program data account. And by create, this is just finding the PDA. So really we don't create anything, we derive. And here it gets interesting as well. It automatically, and I don't think we can disable that, it automatically drains the buffer. Well, that's weird though. Why do we do that early? I do get it that we do it, but why do we do it that early? I guess we still have access to the data even if we drain the lamperts, because only after our instruction the runtime will actually, you know, kill the account. We basically set the buffer lamperts to 0 and add the buffer lamperts. So first we add the buffer lamperts to the pair, and we can first create lamperts, and then if we then destroy the same amount of lamperts, the check is only done by the runtime afterwards. So that's also why we still have access to the data. So we can already close the buffer account here, even though we still want to read from the buffer account. Yeah, we first drain to the payer account, and then we do an actual system program create account to the program data account. There you go. So the program data account is actually created by the BPF Upgradable Loader. So that one you can't create yourself, or you could. No, you can't, because this thing will require you to, where will we see that? Native invoke with a signer. One of the signers, actually the only signer here, is with the seed from the program ID and the bump. That stuff derives the program data account, and so the program will need to provide this in order to do a invoke signed, except it's not doing an invoke signed, it's doing a native invoke, which is a cross-program invocation for a built-in program. And the system program is a built-in program. And we here, the upgradable loader, is also a built-in program, therefore native. Yeah, so where were we here? We have this instruction for that create this account. We create the program data account with at least one lampert, but better the minimum balance for the program data length. Don't ask me why it's minimum 1. This should always give us more. Maybe the minimum balance ever changes to 0. If rent exemption ever goes to 0, then you want to put one lampert there just so the account doesn't starve, isn't cleaned by the runtime, you know. So yeah, good. Why not have a minimum of one lampert? Yeah. And then, yeah, space, that's the data length, and the owner is us, the BPF loader. Yeah, and then as we analyzed, we do this CPI with a native invoke. That finishes the create account. And then we load and verify the program bits. So that's where it then gets interesting. After we have the program data account created, we now write the actual program to it. We get the buffer again, and we do deploy program. Something super native that, I don't know, I guess let's skip this for now. Here's the important part then. From the source slice, we copy into the destination, and that slice has the entire data. We get it from that offset, the entire slice. So the entire remaining data from the buffer account. So the source is from the buffer, the destination is the program data, and then we basically just copy byte for byte the entire slice. And then we set the data length of the buffer account to size of buffer 0. So that resizes the account, but it doesn't really matter because the buffer account has 0 lamperts on it. So if nothing else happens in the same transaction, it will be cleaned anyway to go to completely 0. Here it still has 37 or whatever. Yep, 37. And then we update the program account, set state, program address. Here we go. We write the program data address, the one thing after the account discriminator that this account stores. And we set executable to true. So here is the interesting part. Only the native program can do that. You can't call that, I guess. I mean, maybe you can, but then the runtime is probably going to kill you. Yeah, nice. And then we drop the program and then we're done. And this deploy program macro probably does something internally that tells the validator, hey, there's a new program here or something. I don't know. I don't know what that thing does, but to me, it's not too relevant. What happens on Solana state, we see it here. First, we create the program data account, then we copy byte for byte, and then we write the program data key into the program account and set the program to executable. That's what happens when you deploy. With max data length. Well, so much to scroll here. Deploy with max data length from the upgradable loader. Yeah, and then there are other instructions like upgrade, where it probably works similar, except this time we don't have a create the program data account anymore, but we just overwrite it. There we set state to the current slot, and then again we copy from slice, and the rest, if the buffer account, so the source slice, was smaller than before, then we zero it out. If there's more data at the back, then we fill it with zeros just to overwrite if there was anything else. We don't want any old data in our program account, program data account after the upgrade. If we need more though, then we would need to fund it, and otherwise we spill the rest. And we again kill the buffer completely, also at the upgrade, and the program data will just get as much as it requires. Yeah, that's how the upgrade works. I don't want to look at the set authority. That should be fairly straightforward. You just change the authority. You check, then you also actually check that the authority is a signer. Maybe look at the close. If we close a buffer account, regular close. If we close a program data account, basically I'm building a mental model of what I'm seeing here. It's not super interesting for you to watch this because I'd rather have you go through the code yourself. But essentially, when you close a program, you need to put in the account to close. Then we need some context. Who receives it? The receiver for the lamperts. And that works for an uninitialized or a buffer account. And if we close a program account, a program data account, then we also need to provide the actual program account because it wants to check that those things match, that the program key is actually the same as that program and that we have the authority for it and so on. And then if that all checks out, then we actually close that account as well. And then we just move lamperts, that's it. And set the state to uninitialized just to make sure that in the same transaction it's not messed with, that the program doesn't believe it's still there. Okay, cool. It's the close. That's it then. Well, then there's still the extend that I don't want to have a look at. That's what the upgradable loader can do. Pretty nice. Now, what's that good for? Why would we want to, why did we have a look at all of this? Why do we freaking analyze source code for 10 hours? Well, because now we have an understanding of how that works with the upgrade and the deploy with max data length. So much code, but it's, I recommend that you go through it yourself if you're interested. It's pretty cleanly written. I can easily, for me, it's quite easy to just read this. It's pretty straightforward. And with all the error messages, you get what the code is about. But what is it good for? Why did we do that? What can we do now that we couldn't do before? Well, we can deploy our own program from TypeScript, for instance. We can manually build a transaction that deploys a program without using the CLI. If for some reason we can't run Rust, or for some reason we don't want to use that CLI, or for some reason we just want to practice using the new Web3.js, then this is a perfect opportunity to do that and deploy a program ourselves manually, just so we can say we've done that. Let's just do a manual deploy. pm I Solana Web 3 in version 2 because we want to practice. They're going to rebrand this. They're going to rebrand the Web 3.js in version 2 to something else. I don't know yet. But it is coming, so I do want to work with that version. Besides, I know the other one too well anyway. Wait, I need the system program as well. I just figured. We'll also want this. PMPM I this. And then a key pair. Manual deployer. Yeah, the man. Let me go to DevNet again because it's cheaper and I can get airdrops. We set our key to our man airdrop. And then we go through it. Actually, maybe let's not start with a deploy, but with a create buffer. And I prefer to also have a buffer account like this, buff beer. Actually, maybe I should call it payer. That would be better. Payer and authority are both signers. And then this is the buffer. And so step number 1 really is just to create a buffer account, which if I read that correctly, I just call initialize buffer, and the initialize buffer, no, initialize buffer will just initialize the buffer. I still need to create the account myself. Where was the whole CLI? Here, right? That was the CLI. So here there is no sign for a system program. I need to create this. It's just a create buffer. Which, okay, we should have looked in here. Is a system program create? And I did in fact look in here. I just forgot. Okay, so we need to do a create account and this initialize buffer, which we will need to look at. That is number 0, instruction number 0 will initialize buffer. Okay, perfect. Which means instructions are gonna be create account payer lamperts. How many lamperts do we need for a buffer account? Depends on the size. Let's say our program had, let's actually get a real program. Why not? Let's deploy an actual program. When was the last time I deployed an actual program? When we did the verified builds, I did one that is super small, because I couldn't be bothered to pay for stuff on mainnet. Let's make it say, this is a deployed program. I'm gonna borrow this. Let's call it build. Let's grind ourselves another one for our program pro. We'll need that later. For now, we just create a buffer. So instructions, where were we? Lamperts. Oh yeah, depends on the data size. Create buffer. There we go. 1248 bytes of data size has this thing, which, you know, if we list this, yep, that's what it has. Nice. It's a very small program, but I will still need 2 transactions to deploy this. I mean, to write the buffer. 4 transactions in total then. So first transaction, instructions. Lamperts, now we can get for this data size. Plus 37, I know it by heart. That's the additional bytes that I need. I mean, you know, I could, you know, that's lamperts. What else? The new account will be the buffer address. Wait, I think I need a signer here, so just the buffer. Space will be the buffer size. Program address, because we create the account, will be the BPF Upgradable Loader program, which I don't have, so I got a address of, and I'm just gonna hard code it. Do you think there's a Solana loaders program? Solana program loader or something? Loader. No. Nah, I'm not interested anyway. I'm just gonna do it manually. It's more fun anyway. This guy. Yes, please. So that's the create account, and then we get the instruction for the BPF, but there I don't have the builder, so I'm just gonna tell you, hey, all of those are instruction interface thingies. And here I just manually built this with the following program, the BPF Upgradable Loader. The following data, which is, what do you need? uint8 array of buffer like. Okay, so a new uint8 array of, we said instruction 0 does the initialize buffer. And then the accounts, what accounts do you need? Cheat a bit again. You need the source account, so that's the buffer account, needs to be writable, and then the authority. And if we omit that, then it will be immutable. Maybe we don't want that. Let's make it a mutable buffer, like a normal person would. So 2 accounts. Number 1. Oh, why do you not suggest it? Sometimes the new Web3 JS is a bit annoying. I account matter. Then I can say stuff like, yeah, address and role. That's what I need. Why don't you suggest that down there? Address is payer address and role is account role read only. Then that thing I should be able to put down here, and the second one as well. And it will accept that, but it doesn't suggest it for some reason, and that I find a bit annoying, but okay, whatever. You just need to know how it's done. Okay, anyway, so the payer is the second thing. That's my authority, the second one, and the first one is the buffer actually, and that one needs to be writable. And also a signer, but not in this instruction. In this instruction needs to be a signer. That's why here it's signing. So it's signing anyway for the entire transaction. So whatever. Okay. And then we have the instructions. Oh yeah, you are an array, of course. Good. And that, if we put those instructions into a transaction like this, then we should be able to run it and create ourselves a buffer. Let's see. The simulation fails. Okay. Invalid instruction data. Okay, fair enough. The BPF Loader Upgradable is not happy with our instruction data. Fair enough. Totally get it. Totally get it. I might have messed up something here. Maybe you need more zeros. I'm giving you 4 zeros. That's better. Okay, so apparently here, I don't know. I never know. This is still a bit confusing to me how those enums, how many bytes they need. Because some just need 1, some need 4, some need 2, some need 8. No, that never happened, but maybe. So yeah, you just need to provide enough zeros, I guess. And we will figure out how many zeros we need. The latest when we do the offset, we need to have the correct number of zeros before. I mean, we could look at it, you know, it's not like nobody ever deploys programs. If you were to look at this, any freaking random transaction that does, oh, that's an upgrade, but it doesn't matter. We can still check raw and see, yeah, it needs 4 bytes for the instruction discriminator. Okay, now we know. And we also have the correct data, and we also created a buffer. I mean, nothing special here. We just pay for an account, the buff account, create that account and initialize it as a buffer. Pretty straightforward. Both of them success. Nice. Now that we have a buffer, which has 1285 bytes, 37 are for the metadata and the rest is for the program. So let's write that program. It will need 2 transactions. So let's create a write buffer, which, you know, takes the same buffer account. And the instructions are now not this, but a write instruction, which, if we look at the instructions here, is the index 1, and then it needs offset and bytes. It's index 1, and what accounts does it need? The buffer and the signer, the same accounts. We just leave that, that's perfect. But then it also needs the offset. Or maybe I should get the data out. And we should calculate the chunks. I'm just gonna eyeball it, and I'm saying, hey, I'll deploy it in 2 transactions, and then I'll just do 2 chunks. So my chunk size is just gonna be the data size divided by 2. Yeah, that's fine. That's perfectly fine. Actually, why did I call that data size? This is the actual program data, and the size is .length. Whatever. But then it's gonna get confusing. Binary data, binary program data, because program data is also the name of the account. It's just confusing. Names are confusing. You just need to know what we're talking about. So chunk size is just half the program. Let's just deploy half the program in this one transaction here. And let's do data, move that out, 4 for the offset, and then the actual chunk size. And can I write to this? No. In the new Web 3.js, you have all those encoders and stuff. How do I work with this? I still need to figure out how to properly work with this. I don't know the new Web 3.js. It can't be so deep. I just need to learn it properly once. Somebody should teach me. I need a crash course for the new Web 3.js. Do we have that? And maybe I will just make a whole video on those encoders. For now, we're gonna revert to writing stuff manually. This is ugly as fuck. But since I don't manage to do it any cleaner way, we're just gonna do this. Basically what I did is I did the same as before. 4 bytes for the write, 4 bytes for the offset, but offset is 0. If I wanted to set an offset, I would set it at index 4, but it's 0, so I don't need to do that. Let's see if we can write a buffer like this. You think we can? I'm confident in my skills to manually write buffers. Oh well. Buffer account already initialized. Well, what am I doing? I'm trying to initialize it again, probably. Maybe I should, hold on. They are all 0. Of course they're all 0. Of course that's not working. Why would I expect that that works? You know what? Normal buffers were so nice. Why don't I have a buffer? Oh, hold on. That's in the same package as this, which it also doesn't like. pnpmi types node at types node. Now I have a buffer. There we go. Let's just work with a buffer like a normal person would. And then we can, you know, properly do the things as you properly would with a write uint32. And here actually, instead of this entire freaking stupid loop to copy into, so we need to do it the other way. Fine, I'll just make myself a buffer, I don't care. It's TypeScript. It doesn't need to be efficient. Then we copy into the data buffer. And then we don't need this loop. Yeah, at least we have this now. First 4 bytes, second 4 bytes, and then comes the program data. But invalid instruction data, it still doesn't like this. Okay, that's okay. Let's analyze what we're doing wrong. A U32 is 4 bytes, right? I think so. 4 times 8 is 32. Oh, it's a vector. Yeah, of course it's a vector. Yeah. And the vector needs, guess what? A length. So we need another 4 bytes for the vector length. And then we write the vector length at offset 8. So this pushes to offset 12. And there we write, well, the chunk size. Yeah, because we write... Oh, actually, good point. We don't write everything here. We start at 0, but we just write chunk size for the first chunk. So this is how you properly write to a buffer, right? No, still not. Still invalid instruction data. What have we now? This is the length for the thing. I mean, that looks okay. It's more difficult than I thought. Where am I missing some offset or something? I'm definitely doing something wrong. Right, account data. Directly here, we don't get invalid account data. Probably in the right data where we fail then. Or maybe we are not calling the right. I think we just fail more generically. I'm actually not sure why it would tell me. Probably from this here, limited deserialize. And there it gives me the invalid instruction data. So most likely that's where I fail. I mean, I love working with, you know, low level stuff. But at the same time, it's like, what am I doing wrong? I'm not giving up here. I'm going to figure this out. I probably have a wrong assumption for a length of something. I mean, we can deploy the program to somewhere else even, just to compare. That could help us. I'm willing to do that. Let's do that. The deploy build SO on definite I can't be deployed. See, 2 transactions. It needs 2 transactions. There we go. Program deployed. I'm not interested in a transaction that deployed this program, but interested in the ones before. Here it created the account that we managed ourselves as well though. And in those it writes the account. So let's have a look at this. This must be the buffer account. And then it says write. So look at this in raw. What's the difference to what I have? It has 1, 0, 0, 0. Okay, so far I have the same thing. It has another 4 zeros for the offset. Okay, so far I have the same thing. And then it has F40. And the vector seems to have 8 bytes though. The vector has an 8 byte length, not 4, because then the 7F comes here. Whereas when I did it, my 7F comes here after only 4 bytes of length. So of course, if that's an 8, then that's 16 to have an offset of 16. Yeah, that's cleaner as well anyway. And then we don't write a uint32 little endian. We would write a big int for this chunk size, but it doesn't matter because it's less than 4 bytes or it's less than or equal. It's 2 bytes. Damn it. We will never have more. Whatever. We're not being efficient in packing this, but it's fine. We just send more transactions. Yo. YOLO. But this way, if I now write buffer, yeah, there we go. Now I get success. Isn't that easy? Super easy. Does it actually send? It does send. Okay, so we wrote the first chunk. Should I write the second chunk? Just to deploy it properly, write the second chunk. So we need another write program, and I say 1, starting at 0, of course. So everything stays the same except for the offset, because the offset is now chunk number times chunk size. Oh yeah, and what I write, of course, I need to change what I write. I copy from, good, like this. I should now also be able to write the second chunk. I'm not filling my chunks efficiently, but I know that I just need 2. So I do half, and that also works. Cool. And with those 2 transactions now, I have written the buffer. And now I can do the actual deploy. And what will we need to do? I remember there was a system program something. I create the program account with the system program, because for that I will need to sign. That makes sense. That's why I need to do that. And the program data account is created by the BPF loader. That's why that one I don't need to create. Yeah, that makes sense. It gives me more flexibility in how I create the account, because like that I could also create it with seeds. Because if the instruction would do that itself, if the BPF loader would also create the program account, then it would always do it the same way, or have to have different instructions on do it once with seeds, once like that. No, it just lets you do it. That's actually really smart. I like it. Okay, so like we did in the create buffer, we're gonna do a create account, payer pays, Lamperts. Now this is gonna be program size. The program size will be that plus not 37, but program account is 36. Wait, where's the 1 byte difference here? Program has just the program data address, so that's 32. The buffer has the authority address, but that's an option. That's where the 1 more byte comes from. Okay, get it. So we don't need 37, but 36. Then get the Lamperts for that, and then create that. And the new account will be the program key pair. And we assign it to the upgradable loader. That makes sense. And then we do an upgradable loader instruction with the following data. What do we need to do? We need to deploy with max data length. Max data length. I'll build a buffer again. Instruction number, was it number 2? Yeah, it was right after the write. That's 1, that's 2. Perfect. Easy. Oh, wait, but this one we should probably actually write as a, it will still be okay like this, but just to make sure, we write the entire 8 bytes. It's not gonna be that big. Because if it was actually so big, then we had problem with a 10 megabyte boundary. Yeah, anyway. Yeah, and that should already be it, except maybe we should also put that buffer down here. But now that should be it. And that is all we need for deploying, is it? No accounts? What accounts do we need for deploying? Oh yeah, way more. First of all, the payer to pay for the program data account creation. That shall be my guy, and he needs to be a writable guy. It actually also needs to be a signer. I mean, I'm making sure that he's a signer, because he's my payer, my fee payer as well, but make it a writable signer just to make sure. The uninitialized program data account. Oh yeah, we need to provide all the accounts. And even if the BPF loader initializes it, we need to provide it, because that's how Solana transactions work. So for that, we need to find it. Program data account, await, find program. What was it called? No, it's not called find, it's get program derived address. So confusing. For the following program, the BPF upgradable loader, and the following seeds, both the seeds, the program account. And there we need to decode an address again. I'm getting used to this. Get address decoder, decode program key pair address. And that is the one and only seed. No? Oh, you need the, hold on. We need the address encoder, and then we encode the address. Okay, sure, let's do that. Yeah, why not? And that's my seed. And then I can log it, the program data account. I'm pretty sure that it is what I need. I get also the bump. I don't care about the bump. So here we go. That's just the address. Perfect. Watch my TypeScript tutorial if you don't know what I'm doing here. That should be that account. We're still at the accounts. So the next one is this one. As writable, yes. Doesn't need to be a signer, can't be a signer. Then the next one is the uninitialized program account. Uninitialized but created. So that is the program key pair address, which is also writable. Then we have the buffer account where we read the program from and then it's being closed. Buffer. And then the rent sysvar and the clock sysvar. I'm sure the sysvars are somewhere in the Web3.js, same as this guy. But at the moment I can't be bothered to find out. There you go. Just manually copy them in. And then we get the rent, read only. Then clock, then system program address. Nice, this one I have. And then comes another signer, the program's authority, which is once again my payer read-only signer, but we know that it's a writable signer because that's what I define here. Cool, and like that, I should be able to actually deploy this program, right? Because we do have the buffer account. You know, this is one of the few instances where you have a buffer account with a full program loaded, because usually you immediately after deploy it. So if we look at this buffer account, it actually holds the data, but not for long anymore. Because now we're gonna deploy. Deploy! No. Oh, failed to parse ELF file. Invalid section header. Wow, when we deploy, it actually reads the ELF file that it's a valid. Cool. So my writing was not correct. I might have messed up some offset or something. Invalid section header. So it does checks before. We can't deploy if we don't have a proper program. That's cool. If it was just invalid account data for instruction, I would be like, yeah, what does that mean? But with this, I mean, I could now go and read the buffer account and see what I've written there. I mean, let's do that. Solana account. Show me what you got. A bunch of zeros. So it seems to, there we go. Those are the first, and then that's the authority. And then here starts the program. That looks good. That's the byte that my program actually starts with. So that should be fine. The first, I don't know, 600 whatever bytes. We even see that this is a deployed program that also made it in there. But then from roughly half of it, is that roughly half? Yeah. The second half, maybe the second transaction just didn't go through or had the wrong offset, because the rest here is all 0. And if I print my program, I mean, there are a lot of zeros at the end, but at least here I have 1, 1. So it's not completely all zeros like here, but I don't see any 1 here. My second write has probably not worked correctly. So I have chunk number 1. So 1 times chunk size is my offset, which I write into the offset. Then I write the chunk size, and then I write, hold on. Oh, I see my problem. I was writing 0 bytes. I need to write offset plus chunk size for the target here as well. I missed that. That was my bug. So we will need to write that thing again. We need to write the buffer again. Success. It just takes that. And now we should be able to deploy. Nope, still invalid section header. But did it write now properly? Can we check that account? Still didn't write it correctly. Write buffer again. You know, it has the right length, but then it's all zeros. Hold on, here it shouldn't have this offset. Ah, here it should start at 16. Then the offset just within the, yeah, that makes more sense. Okay, another bug. We found another bug. Okay, but now, yeah, at least we're writing some stuff now. Perfect. And if we now check the account, yeah, now we also have some stuff in here. I told you there's a 1 and stuff. Nice. And that text also got entry point. Entry point.sol log. Nice. Got completed. So now it looks complete, at least to me. Now we should be able to deploy it though. Yes! Success! We deployed the program manually with our own transactions that we built in TypeScript. Cool! And the buffer account, if we refresh this, the buffer account now doesn't exist anymore. It's gone! It's gone! Because that's what the deployment does automatically. It kills the buffer account. It kills the buffer account, but therefore funds the program data account, which is this one, the E6, which we also saw here in my log, the E6, we derived that. Nice, that worked. Cool, yeah, and this one I created manually with this system program create, and then the BPF loader made it a program and set this one to executable true. So this one is now an actual executable program. Wow. Yeah, and that's how you do this by yourself. Cool, deployed program. Bam, it even logs this. Nice. Now, does that actually work? I mean, we trust that it does, but we could also check that it does. Call the program. We only do a instruction to the actual program key pair address. So our program. We don't need any data, and we also don't need any accounts. That's it. That's how you call it. Call it, and this is a deployed program. You can call it. It's an actual transaction. There you go. That calls the program that I deployed manually. Haha, amazing. That is so cool. Okay, one last thing that we do now. Just because I promised you that I would look into this as well. And we already know what happens if we close the program. If we close the program, this account will stay the exact same, this one. Except it might lose its executable flag. Maybe. We'll see. But what will change is the executable data account. This one will go and will just be emptied. So let's call the close. Doesn't take any instruction data and has the 4 accounts. Account to close. For closing a program, that must be the program data account, because you can't close the program itself. That account never goes. The account to deposit the funds in, the authority, and the associated program account if we close the program data account. Cool. We call the BPF loader. We need the program data account, and then basically twice my payer, because he's the authority and the receiver. Make sure that is here it is writable and here it is a signer. Not sure in which order. Writable and signer, yep. And both of that together will make it a writable signer, but don't tell it. Also, my fee pair will make it a writable sign-up. But, you know, been saying this 3 times now, it's enough. And then the program key pair address is the 4th one, and the rest, that's fine. That's all we need. Program data account, that's the one we close. Receiver, authority, program account. Does that need to be writable? Yes, that actually needs to be writable. So probably we change the executable flag or something. But like that, we should be able to close the program. Let's see. Can we close the program? No. Oh, wait. Yeah, of course, because we're not calling the close. We're calling, what are we calling? Something. We're calling nothing. We need 4 bytes again. And secondly, the close was which? 0, 1, 2, 3, 4, 5. 5. Here you go. And like this, I should be able to close. Success! We successfully closed the program Pro. Nice. And if we now refresh this executable data account, it will be inexistent. But therefore, the program account, hold on, where is it? This one, still the same. And indeed, executable is now no. Even though it is owned by the BPF loader, it is still not executable. Nice. And we can never reopen this. We cannot deploy to this anymore. Actually, what happens if we try? I will never finish this video. It's just so interesting. If we go through the same steps again, create a buffer, write the buffer, make a loop for this, or I do it manually. I also need to write the first chunk. And then I try to deploy again. Account address already in use. We cannot deploy because that account is already in use, of course. What if I wanted to upgrade? Instead of deploy, we upgrade. Account not large enough. Account data too small for instruction. That's what we fail with? I mean, okay, yeah, sure. But also I cannot, I guess also the extend will fail because the account doesn't exist. So I guess that's how we're safe to redeployments. We get an account not large enough. Yeah, fair enough. Okay. And I'm not gonna bother with, you know, deploying another program, upgrading that to prove that I can upgrade. I guess you got the idea. Now, can I have a valid program that is so small that I can deploy it in one transaction entirely? That would be a fun thing to do. Where did I do the smallest possible program? When I did assembly. Smallest one must be with assembly with just 1 exit code. So how big is that? I think they're also so big. Even that needed 1400 bytes. So even writing an assembly program, I couldn't get it so small that I can fit it all in one transaction. Because theoretically, you could do all of those things, right? You create the buffer, you write the buffer, and you deploy the program. You could do it all in one transaction, but then there's not much space for actually writing much data. So you will need your 3 transactions, or maybe 2. You get the idea. It's an esoteric use case anyway. Yeah, that's that. Easy. We learned how to deploy programs manually, and we learned how the deployment process works. I am happy with that. So happy that my freaking forehead sparkles. Ah, brightness. Okay. Good. I'm okay with that. Because this has been a long journey now anyway. I hope that you learned something. I did. First of all, I now know what the definition of a program is closed is. It's that the executable data account is closed, but the program data account is still there. And I also learned the exact steps how it is deployed and what's happening behind the scenes. And that actually the BPF Upgradable Loader always kills the buffer account. I mean, it doesn't kill it, but it steals the lamperts from it. So you could refund it later if you want it to live on. But it definitely takes off the lamperts and changes the size to erase all of the data. You could then again use it and resize it and reuse it. That would work. But that's interesting. I certainly learned a bunch and got some practice in using the new Web3 chairs and calling programs manually myself. After you've done it once, it's super simple to, do the other things of the program. It's just putting in the right accounts and the right instruction data. The Upgradable Loader is a simple program to call, and it's such an essential program that I really wanted to have a look at it. And I did. And it's nice. So yeah, cool. Hope you got something out of this. Watch some other videos. Here's the one with the program accounts if you've still not watched this one. And otherwise, you can subscribe, like this video, and I will see you in my next deep dive, where we analyze another program or do something else. I don't know yet. We'll see. See you then.